Okay, so in looking at this particular problem here, we need to show that this statement is true. So we need to find dx dt and the second derivative as well. And here we go. One thing to make sure that you're clear on is that it's root 12 times t is on the outside. It's not underneath the square root. We also have to recognize that there is a product going on here. It's two separate functions multiplied. So the product rule says f prime g plus g prime f, or the order doesn't matter because it's adding. So dx dt is going to be, I'm going to do the first one, the derivative of the first one is going to be negative 2e to the negative 2t times, and I don't need that parenthesis, times cosine of root 12t plus, I write e function multiplied times the derivative of the cosine root 12t. So the derivative of cosine is a negative sine root 12t. Chain rule inside says multiply by root 12, and I get this here. And then to simplify this a little bit to make life easier, I'm going to pull out an e to the minus 2t, which gives me negative 2 cosine root 12t minus root 12 sine root 12t. Okay, continuing on, so now to find the second derivative of this. So now to find the second derivative of this particular function, the squared x times dt squared. Again, I have a function here times another function. So again, I'm going to have to use the product rule. So the first bit is going to be e to the minus 2t times the derivative of that is minus 2. And then I can just write this out here, cosine root 12t minus root 12 sine root 12t plus e to the minus 2t times the derivative of this particular function here. So the derivative of cosine is a negative sine, so it's a positive 2 sine root 12t times root 12 minus, and here is going to be the derivative of sine is cosine, so root 12 cosine root 12t times root 12. Okay, and so if we start to tidy this up a little bit, I'm going to pull out the e to the minus 2t, and I get this minus 2 is multiplied by both of these, so that means it's going to be a 4 cosine root 12t. The minus and the minus makes a plus, so plus 2 root 12 sine root 12t. Here we're going to get plus 2 more root 12 sine root 12t, and those root 12s multiply to get a minus 12 cosine root 12t. And so if I look at this, I have in total, I get e to the minus 2t. These I can bring together to get a minus 8 cosine root 12t. And here I have 4 plus 4 root 12s sine root 12t. So the next step that we have to do in doing this, we have to go to the scenario that says d squared x over dt squared plus 4 dx dt plus 16x is 0, if I've remembered that correctly. And then I just have to take these values and plug them in. So the first one's going to be e to the minus 2t minus 8 cosine root 12t plus 4 root 12 sine root 12t plus 4, and that's going to be e to the minus 2t times, looking up here, minus 2 cosine root 12t minus root 12. Oh. Okay. Minus root 12 sine root 12t plus 16, and the original function was e to the minus 2t. I believe it was cosine root 12t equal to 0. All right, so distributing these values here, I get negative 8 e to the minus 2t root 12t cosine in here, plus 4 e to the minus 2t root 12 sine root 12t, plus 4 e to the minus 2t. Distributed in here, I get actually 8, and it's going to be, let me try that again here. It's going to be minus 8 e to the minus 2 cosine root 12t minus 4 e to the minus 2t root 12 sine root 12t, and then finally plus a 16 e to the minus 2t cosine root 12t equals 0. All right, so there's a lot of ones in here, and so if I consider the cosine here, minus 8 more cosines plus 16 of them, these all cancel out. If I look at the sines, they also cancel out, and so it equals 0. So the first part is done. So in this problem here, we're going to work on C part. And in order to get the C part, let's talk about find the time when the bearings first comes to instantaneous rest, and then its distance from the equilibrium position at this point. So we need to, from the first part, we need to find some value of t, and then from there, we're going to plug it into this equation. So if it's instantaneous rest, that means when is the velocity dx dt equal to 0? And if we calculate dx dt, which I did on the previous video, but I'll do it quickly here since I don't have it written down, I get e to the minus 2t times negative 2, because the chain rule, times cosine root 12t plus the e to the minus 2t times the derivative of the second function, which is negative sine root 12t times root 12. And I'm going to set this equal to 0. And the easiest way I can do that is if I come over to go over to my calculator, and if I choose to graph it, it's here actually, I can't see it, and I use Desmos because of the iPad doesn't do the other stuff well. You find the first point of intersect where it's 0, because you want the derivative equal to 0, and you get 0.756. So then I get 0 is 756. So to find the position, I go x at 0.756, which will be e to the minus 2 times this value, cosine of root 12 times 0.756. And if you throw that into your calculator, and if you're in radian mode, you should get, I'm just looking at the answer key here, negative 0.191 meters. When we go on to D part, find the maximum speed of the particle during its first second of motion. So if I want the maximum speed, so if here is my velocity curve, let's say I have a velocity curve, this here is the maximum curve. So that means when is the second derivative, which we found in A part, equal to 0? You find the t value. I will solve this with the graph. Find the t value, which I know is 0.151 from the answer sheet. Once you have that, again, you plug that value into, once the maximum speed, you plug it into the first derivative. this first derivative. And then if you want to find the distance, you plug it into the x value. Hopefully that helps.